Hello everybody, and welcome to part B of exercise 8. This is another example of determining the interval of convergence of a power series. So we're going to start this the same way that we did in part A, using the ratio test. All right, so we'd like to take the limit as n goes to infinity of the absolute value of an plus 1 over an, where an again is just our name for the general term of our series. All right, so if we write down the pieces here, an plus 1 is just going to be that same formula for an with n plus 1 substituted in for all the n's. Okay, if we take that and divide it by an, that's the same as multiplying by the reciprocal of an, which would be n factorial over 3x to the n. Okay, and then let's see. So do we get any cancellation here? Well, one thing I notice is we've got a 3x to the n in the top, n plus 1 in the top, and a 3x to the n. That's going to leave a 3x up here. Okay, and we can, since that 3x doesn't contain any n's in it, we're free to move it outside of the limit sign. We just have to remember that we're taking the absolute value of things. So when it comes out, we're going to get a 3 absolute value of x, okay, times the limit as n goes to infinity of n factorial over n plus 1 factorial. Okay, now depending on how much work you've done with factorials, you might be able to do this calculation in your head the next one. But if not, that's okay. We can write out the details and see what happens here. So remember what it is that n factorial represents. It's just a way of writing 1 times 2 times 3 and continuing until you get to the number n. And n plus 1 factorial, same deal, just that we're going to start at 1 and we're going to continue until we get to n plus 1. Okay, but that would mean then that the integer that comes right before n plus 1 is n. And so you can kind of see what happens here then. We get a lot of cancellation. This product of 1 through n, all of that cancels out, and what we wind up with here is just 3 absolute value of x times the limit as n goes to infinity of 1 over n plus 1. Okay, but notice that the value of that limit is just 0. We've got 1 over a denominator that's getting bigger and bigger, and so we wind up with 3 times the absolute value of x times 0, and it doesn't matter what number x is. If you multiply it by 0, you're going to get 0. Okay, so there's our value of r in the ratio test. Okay, what does that mean? Okay, well, if you think back to what the ratio test says, it says that if you do the ratio test, you get a value of r that's less than 1, you have a convergent series. So the fact that we got 0 for every value of x means that this is a series that always converges. Doesn't matter what the x is, we're always going to get 0 for that r. All right, so let's see if we can put that into words. Since that r is equal to 0 for all values of x, the series converges for all values of x. Okay, but if it converges for all x, that means the interval of convergence is everything, all real numbers. Okay, and we could write that down by just saying negative infinity to infinity. The entire real line, for every single x value, we get a convergent series.